Okay, so in our previous video, we learned what integers are, how to compare them, and how to add them. In this video, what we're going to do is we're going to learn how to subtract integers, how to multiply integers, and how to divide integers. So let's start with subtracting, and specifically with subtracting positive integers. Now the first thing you should know is that subtracting positive integers is exactly the same as adding negative integers. And we see this in example 6. So we see here our problem is 2 minus 5. And that is exactly the same thing as saying 2 plus negative 5. And it amounts to minus 3. So in both cases, subtracting positive integers and adding negative integers, we move to the left on the number line. So that's the decreasing direction. Both of these operations, subtracting a positive integer and adding a negative integer, are, again, exactly the same. So let's begin here and try to do some of these problems. So in these problems, we subtract positive integers. Let's try problem A. So this problem is negative 3 minus 5. Well, because we know that subtracting a positive integer is the same as adding a negative integer, we know that this problem, negative 3 minus 5, can also be written in the following way. Negative 3 plus negative 5. And that problem amounts to 8. Okay, negative 3 plus negative 5 equals 8. So this we will remember from the previous lesson, where we learned that adding two negative integers, sorry, that should be a negative 8 there, that adding two negative integers will give us a larger negative integer. So the same way that 3 plus 5 equals 8, negative 3 plus negative 5 equals negative 8. So let's move on to the next problem, problem B, and that's negative 100 minus 100. Now, again, subtracting a positive integer is the same as adding a negative integer, so we can rewrite this problem as negative 100 plus negative 100. And that equals negative 200. Again, the same way that positive 100 plus positive 100 equals positive 200. Now, let's also look at example C. And in this example looks a lot like an elementary school subtraction problem. This is just 35 minus 5. Okay, what? You already know it's 30. You don't have to dig much deeper into it, except that you should know at this level, at the grade 9 level, that this problem, 35 minus 5, can also be rewritten as 35 plus negative 5. So this problem, 35 plus negative 5, is exactly the same as this problem, 35 minus 5. That's what you should know at this level. Again, looks like a problem that you've seen in elementary school, and you have seen problems like this. At this level, the difference is that now you know that it's the same, that subtracting a positive integer here is the same as adding a negative integer. Okay, I'll leave you to do the rest of the problems in the set practice 7 yourself. Let's scroll down and take a look at practice 8. So practice 8 is a word problem, and the problem is this. The temperature of water in a pot is 78 degrees Celsius. How much hotter does the water need to be to start boiling? The boiling temperature of water is 100 degrees Celsius. So again, this is just a problem of subtracting a positive integer. So in this problem, we want to find the difference, or the gap between 100 degrees, which is where we want the water to be, and 78 degrees, which is where the water currently is. So we would set it up like this. 100 degrees Celsius minus 78 degrees Celsius. And if we do that subtraction, that is 100 minus 78, we will end up with 22 degrees Celsius. So the answer to this question would be that the water needs to be 22 degrees Celsius hotter than it is now. Again, a question like this can also be rewritten like this. So if the question is 100 minus 78, we can rewrite it as 100 plus negative 78. So depending on how you find it easier, the point is just to understand that these are equivalent, that they are the same problem. Okay, so on the next page, the basic idea is that subtracting a negative integer is exactly the same as adding a positive integer. We see this here in example 7. So looking at example 7, the problem is 2 minus negative 5. And another way of writing that is 2 plus 5. So when we subtract a negative integer, we move to the right on the number line, so in the increasing direction. So it sounds like there's a lot of subtraction going on here, right? So we're talking about subtracting and we're talking about negative. So it sounds like what's happening is we're decreasing. Actually, we're increasing because we're subtracting a negative. We're taking a negative away. So when we take away a negative, we produce an increase in the value of the integer. So with these tiles here, with these green tiles, we see that there's an addition of 5. That's the same as a subtraction of negative 5. It just will appear to us as an addition. Okay, so let's look at some practice problems again. In practice set 9, let's start with A. And that problem is 4 minus negative 5. Well, since we know that subtracting a negative integer is the same as adding a positive integer, we know that we can rewrite this problem as 4 plus 5. And that you already know. That's an elementary school addition problem. 4 plus 5 equals 9. Now, let's look at problem B now. Problem B is negative 95 minus negative 5. So, we can rewrite this, right, knowing that subtracting a negative integer, the same as adding a positive integer, we can rewrite this as negative 95 plus 5. So, the question here, again, is pretty simple. How far to the right on the number line will we move from negative 5 if we're adding 5 to it? Okay, so we move 5 integers to the right on the number line. That will bring us from negative 95 to negative 90. And notice again that this looks a lot like a similar problem, which is the problem positive 90 minus positive 5. And that equals 90. So these problems look similar, except they're going in a different direction. Sorry, I meant to write here positive 95 rather, minus 5 equals 90, right? So these problems look fairly similar. They're just moving in a different direction. This problem, negative 95 plus 5, moves in the increasing direction. And this problem, 95 minus 5, moves in the decreasing direction. Let's do one more example problem here from practice set 9. And that's problem M. Now problem M looks more complicated, but it works in the exact same way. So we start with 3 minus negative 4 minus negative 2. Okay, so 3 stays the same, but we can rewrite this problem as well. Knowing again that subtracting a negative number is the same as adding a positive number, we can rewrite this problem as 3 plus 4 plus 2. Right? 3 plus 4 plus 2 equals 9. So 3 minus negative 4 minus negative 2 equals 9. Practice 10, I'll leave for you to do by yourself. But just remember that it works in the exact same way as the problems that we've just covered. Okay, let's try practice problem 11. The problem is this. Newton is climbing up a 1,200 meter high mountain. He starts at 50 meters below the sea level and then climbs 250 meters up. He then takes a break and continues to climb another 425 meters. Newton then realizes that he dropped his lunch bag on the way and returns 205 meters to find it. Then he continues climbing for another 485 meters. Okay, so what we want to do with a problem like this is we want to set it up to look like the problems that we've been doing in this section. So this is a problem of adding and subtracting integers. So let's start with A. How far above the sea level is Newton now? Here's how I would set this up. Where does he begin? Well, he begins at 50 meters below sea level, so at negative 50 meters. The question is, remember, how far above the sea level is Newton now? So he begins at negative 50 meters. Then what does he do? He climbs 250 meters up. So let's add 250 meters. Then he takes a break and climbs another 425 meters. So we add another 425 meters. Then he realizes that he dropped his lunch bag, and of course you need your lunch bag to climb. He returns 205 meters to find it. So he is actually returning the way that he came. That means that he's going back. So his altitude, his height on the mountain will decrease at this point. So what we're doing is here we're subtracting 205 meters, which is, as you remember, exactly the same as adding negative 205 meters. So then, once he's found his lunch bag, okay, hopefully he found it, he continues climbing for another 485 meters. So we add another 485 meters. He's going 485 meters higher. Now you just do the additions and subtractions as you usually would. So what I would do with a problem like this, because this is like 5 numbers at this point. It can get a little confusing, it can get a little much. So what I would do is I would take the positive numbers and I would group them together. Then I would take the negatives or the subtractions and I would group them together. I would do the problem that way. So let me show you what I mean. And again, this is one way of doing it. There are other ways as well. But here's how I would tackle this. So start with the positive numbers. That's 250, 425, and 485. Let's bring them together first. So 250 meters plus 425 meters plus 485 meters. Then, let's do the subtractions, or the negative numbers. Minus 205 meters minus 50 meters. Okay, so we add together the positive numbers first and then the negative numbers. So 250 plus 425 plus 485 equals 1160 meters. So now we're at 1160 meters minus 205 meters minus 50 meters. So remembering that minus 205 minus 50, if we were to take this section of the problem, minus 205 minus 50, the subtraction of the positive integer 50 is the same as adding a negative integer, negative 50. So we can rewrite minus 205 minus 50 as minus 205 plus negative 50, which equals to negative 255. So that means that this 1160 minus 205 minus 50 will equal 1160 meters minus 255 meters. From here on out, it's just a simple subtraction problem. So 1160 meters minus 255 meters equals 905 meters. So this, hold on, let me just remove this. This once again is for problem A. How far above sea level is Newton now? Newton is 905 meters above sea level right now. Okay, let me clear this stuff so we can get to problem B. And that problem is how much farther, right? How much more does he need to climb to reach the top of the mountain? Well, we know that our answer for A, having done the problem, is that he is 905 meters above sea level. So the complete answer to this question is Newton is 905 meters above sea level. How much farther does he need to climb to reach the top of the mountain? That's, again, a subtraction problem. So the top of the mountain, how high is the top of the mountain? It's 1,200 meters. And we want to know the difference between the 1,200 meters, that's the height of the mountain, and where Newton is now. So we set it up as 1,200 meters minus 905 meters. From there on out, again, it's just a subtraction problem. 1,200 meters minus 905 meters is 295 meters. So the full answer to this question would be that Newton needs to climb 295 more meters to reach the top of the mountain. Now, this problem, with high diving in the ocean, as well as this next page, which features the concept of appreciation and depreciation, as well as some more stuff about atoms and ions, which we kind of looked at in the last video, I will leave for you. I'll leave this page for you, and I'll leave the previous problem, the problem with high diving in the ocean, for you to try yourself as well. And we'll move on to the concept of multiplication and division of integers. So with multiplication and division of integers, let's first get into multiplication. Recall that the basic idea of multiplication is that it's a repeated addition. Every multiplication tells you how many times to add that same integer 2 itself. So we can use multiplication instead of repeated addition. So here's the example. This is a simple and classic example. 3 plus 3 plus 3 plus 3 plus 3 equals 15. Okay, that's a long way of writing it. We can write it as 5 times 3 equals 15, or 3 times 5 equals 15. This is telling us how many times we add the number 3 to itself and get the answer 15. So multiplication can be written in a few different ways. Often we use this sort of cross. It's a sort of a sideways cross, looks like an X. In this course, we don't like to do that. The reason we don't like to do that is because it gets confused with the letter X. So sometimes in elementary school, you will see this. This is used less often in high school because in high school, you're going to be doing algebra. You're going to see the letter X a lot more in math. So it can simply get confusing. So we prefer to use the dot as a way of denoting multiplication, or to simply put two numbers beside each other in parentheses, and that means multiplication as well. As this note says, in higher grades, once you get to the concept of vectors and tensors, there's a difference between dot product and cross product. That's not something to worry about at this point, though. At this point, all you have to know is that all of these methods of writing multiplication are perfectly valid, and that in this course, we are going to tend to use the dot method or the parentheses method, so putting two numbers in parentheses beside each other. Division can also be written in a few different ways. Division has its own characteristic division symbol. It can also be designated with a slash, or in the form of a fraction. So when you see a fraction, fraction is equivalent to a division. So the fraction 15 over 3 is exactly the same as 15 divided by 3. Both are 5. So let's do some practice problems. And let's do practice 15, problem A. So what's the task here? The task is to express each repeated addition as a multiplication. So we remember that multiplication is nothing but a repeated addition. So what is going on here? This is 2 plus 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 2. Okay, gets me tired just saying it, but what you want to do here is you want to count how many times 2 is being added. Once you know how many times 2 is being added, you know what number 2 is being multiplied by. So, how to express this as a multiplication? Well, you know that the number being multiplied is 2. Now, how many times is it being added? So what number is it being multiplied by? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 2's. So the answer in this case is 2 times 8, which we can also write in this way, 2 times 8 with the cross, or in this way, 2 times 8 with parentheses. Let's do another problem. And let's do problem F. Why not? That's a similar problem, works in the exact same way. Except instead of a number, we have a letter or a variable. But again, it works in the same way. So, first, the number that's being multiplied, or the variable rather, that's being multiplied is a. Now we have to ask, what is it being multiplied by? So, how many times is it being added? How many times are we repeating the addition? Let's count. 1, 2, 3, 4, 5, 6, 7. 7 times. So, to express this addition as a multiplication, we could say a times 7, or a times 7 with the cross, or a, let's just make it clear that this is an a times 7 in parentheses. Now, you'll see also that when you use variables, you don't really have to use these parentheses. You can also express this as 7a, not generally as a7. That's not something we tend to write, but 7a is also a perfectly fine way of expressing this multiplication, a times 7. All right. Let's clear this and look at some problems from practice set 16. Now, express each multiplication as a repeated addition. So we saw in practice 15, we were given a repeated addition. We have to make it a multiplication. In this case, we already have the multiplication, and we want to see what additions are signified by it. So what are the additions that are going on in this multiplication? So let's start with a. The problem is 5 times 2. So the number 5 is what's being multiplied, and 2 is what it's being multiplied by. So 2 is going to tell us how many times the number 5 is being added. How many times? 2 times. So 5 times 2 equals 5 plus 5. 2 5s. Now, let's look at C. 4 times 4. So, once again, first number we start with, that's the number we are adding. Times 4, that's how many times we add it to itself. So, in this case, we want to take the number 4 and add it 4 times. So it amounts to 4 plus 4 plus 4 plus 4. 4 times 4. 4 plus 4 plus 4 plus 4. Now, let me clear this away so we can look at another problem. And this is an interesting one. D, 5y. Right? So we remember that in practice 15, we were able to write a plus a plus a plus a plus a plus a plus a as 7a. That was one way of writing it. Another way of writing it is 7 times a, or 7 times a with a dot. So another way of writing 5y is 5 times y, or y times 5, if you like. So here's the number, or the variable in this case, y, that we are adding, and how many times are we adding it? We're adding it 5 times, because we've multiplied it by 5. So 5y could also be written as y plus y plus y plus y plus y. 1, 2, 3, 4, 5. That's y 5 times, or 5 times y. So multiplication with negative integers works in basically the same way as the kinds of multiplication that you've already seen. So the kinds of multiplication you might have done in elementary school. The only difference is that when negative integers are involved, you have to really keep track of which integers are positive and which are negative so that you know whether the answer is positive or negative. So with both dividing and multiplying integers, the rules are basically the same. If both of the integers that you're dividing or multiplying are positive, then the answer is positive. If both of them are negative, then the answer is also positive. But if one of them is positive and the other is negative, then the answer is negative. And you see that this that these rules are basically the same for multiplying and for dividing, right? If both of them are positive and both of them are negative, then the answer ends up positive. If one of them is positive and the other is negative, then the answer ends up negative. Other than that, the multiplication itself or the division itself basically is the same. So the number that you end up with, you will end up with it in the same way as the kinds of multiplication and division that you're more familiar with. The only thing you have to watch out for is the answer positive or is the answer negative? So let's look at some of these practice problems. Let's look at practice problem 17. And let's start with A. So A is 3 times negative 3. Okay, we know that 3 times 3, okay, let me write this here. 3 times 3 equals 9. But this problem is not 3 times 3. This problem is 3 times negative 3. So which of these rules applies? Well, we have a positive integer and a negative integer. So our answer is going to be negative. So just like 3 times 3 is 9, 3 times negative 3 is negative 9. Let's look at another one. Let's look at S. S is negative 8 times 5. So again, you already know that 8 times 5 equals 40. But this problem is not 8 times 5, it's negative 8 times 5. So which rule applies here? The rule that applies here is that a negative times a positive will give you a negative number. So negative 8 times 5 is negative 40. Same way that 8 times 5 equals 40, right? 8 times 5 is a case of a positive times a positive number. That gives you a positive result. In this case, we're doing a negative number times a positive number. That will give us a negative result. Let's do another one. 7 times negative 7. 7 times negative 7, again, is a positive number times a negative number. So we know that 7 times 7, right? Positive 7 times positive 7 equals 49. But positive 7 times negative 7 equals negative 49. Because a positive number times a negative number equals a negative number. Now let's do one more, an example of division. That's example Z, practice problem Z. 24 divided by negative 6. Okay, so we know that 24 divided by 6 equals 4. But these are two positive numbers, whereas in this case we have a positive number and a negative number. So what rule applies? Right? Positive number divided by a negative number gives us a negative result. So the division works in a pretty similar way, except that the result will be negative. So 24 divided by 6 equals negative 4. So the problems in practice 18 are basically, they work the same way as the problems in practice 17. Let's look at a few of them together. So problem A, 2 divided by negative 1. So the division itself works basically the same as the problem 2 divided by 1. So 2 divided by 1 is just 2. But the problems are not the same because, again, in this problem, 2 divided by 1, we're dividing a positive number by a positive number. And we get a positive number as a result. But here, 2 divided by negative 1, we're dividing a positive number by a negative number. So our result will be negative, according to the rules that we've been working with. So 2 divided by negative 1 is negative 2. Let's look at another problem. Problem G. That is negative 12 divided by negative 4. Now, negative 12 divided by negative 4 works in terms of the division similarly to 12 divided by 4. And that equals 3. But whereas here we're doing a positive number divided by a positive number and we get a positive result, in problem G we have a negative number divided by a negative number. But a negative number divided by a negative number is, according to the rules we've been using, also giving us a positive result. So negative 12 divided by negative 4 also equals positive 3. And let's look at one more problem. Let's look at problem I. So problem I is negative 8 times 3. Right. So negative 8 times 3, in terms of the multiplication itself, will look a lot like 8 times 3. Right. So 8 times 3 equals 24. But 8 times 3, remember, is a positive times a positive, whereas problem I, negative 8 times negative 3, is a negative times a positive. So, again, looking back to the rules we've been using, the answer to this problem, to problem I, will be negative 24. So now, oh yes, so here's a reminder that division by 0 has no meaning. That's undefined. When you see a number divided by 0, that's an undefined value. So we won't be getting that much further into that right now. So practice 19 is a sort of theoretical problem. Kimiko multiplied two negative integers together. She then multiplied her answer by another negative number. Is her final result positive or negative? So the way I would think about this problem is keep track, right? Keep close track of where the numbers are positive and where they're negative. So first she multiplied two negative integers together. So that value that she got when she multiplied two negative integers together, is that a positive value or a negative value? Well, according to the rules we've been using, multiplying two negative integers together will give us a positive value. Let's go back to Kimiko. She multiplied two negative integers together. So she now has a positive integer on her hands. She then multiplied her answer, which we've determined was positive, by another negative number. So she multiplied a positive number by a negative number. What is the rule for that? Let's go back and see. A positive number times a negative number will give us a negative number. So her final result is negative because she multiplied two negative integers together and got a positive number. Then she multiplied that positive number by another negative number. Her answer then is going to be negative. Okay, so we've got time to look at one more word problem. Why don't we go with practice 21? So the problem is the following. Tao has $12. He gets $5 bills 3 times and gives away $2 coins 5 times. How much money does he have now? So we want to set this problem up basically in a way that will make it look like some of the problems that we've been looking at so far. And the question is just, how much money is he going to have at the end of this process? So he starts with an amount of money, he gains some money, he loses some money. How much money does he have at the end? So how much money does he start with? Well, the problem tells us Tao has $12. That's how much we are starting with. That's how much he has at the beginning. So that's how much money is going to be at the beginning of our problem. $12. Then he gets $5 bills 3 times. So we are adding 3 times $5. And then he gives away $2 coins 5 times. So let's add 5 times negative $2. Or how will I write negative $2? How about negative $2, like this. So now we have basically two kinds of problems, addition and multiplication. So let's solve some of these problems. So again, the 12 we're starting with is going to remain unchanged, but now we are going to multiply 3 times $5. So that's a multiplication of a positive number and a positive number. So that's going to give us a positive result. 3 times $5 equals positive $15. But here, when we add the 5 times negative 2, that's going to give us a negative result because we're multiplying a positive number by a negative number. So 5 times negative 2 is going to equal negative 10. So it would be $12 plus $15 plus negative $10. But we know from before, right? So remember that adding a negative is the same as subtracting a positive. So we can rewrite this problem in the following way. $12 plus $15 minus $10. Now, from here on out, it's just a simple addition and subtraction problem. So we can start with 12 plus 15 and then subtract 10 from it. So we would get $27, right? That's 12 plus 15 minus $10. And then just do the final subtraction and end up with $17. So if Tao starts with $12, gets $5 bills 3 times and gives away $2 coins 5 times, he will end up at the end with $17. So at the end, right now, Tao has $17. So as for the rest of the problems, I'll leave them for you. They work in basically the same way. The challenge problems are a little bit different. They require a little bit of harder and different thinking, but that's why they're challenge problems after all. Okay,